Hi everyone, welcome to Scaffolding, the solution to tough time-based problems. My name is Archana Ganeshlingam and I'm a senior product consultant based over in our London office. Last year, I had the pleasure of delivering this session at our conference in New Orleans, and I'm excited to be able to deliver it again here in Berlin. Unfortunately, this time around, though, I won't be presenting with my usual partner in crime. Her name's Sasha Singh. She's another product consultant based in Austin, over in Texas. But you'll come to find out why we're wearing these silly hats as part of this session in just a second. And I don't have mine with me, unfortunately, today because it doesn't fit in my hand luggage to bring it across for the week. So, on to kind of rough agenda for what we're going to be covering today. During this session, you're going to become familiar with a mantra. Data stored efficiently isn't always stored effectively. And I'm going to come on to what that means in just a second. I'll cover how to recognize situations where you may need to use what I'm going to call a scaffold table to pad the data. But what this means is adding additional rows to represent gaps or missing data in the data set. So you might have heard other words for it. Data densification is another common term used for this concept as well. And of course, I'm going to be showing you how to do all of this in Tableau Prep. It's kind of one of the newest tools on the Tableau platform. But as I go through each of these examples, keep in mind that everything I show you today can be done in Tableau Desktop, or if you prefer, in the back end of the database. I like using Prep to do it because I think the visual and direct approach makes it really easy to see what's happening when we start to duplicate that data out, and also what happens when you come on to then apply filters. It's also worth mentioning that now with data management from Tableau, you'll be able to schedule these flows, so these tasks that seem complicated only need to be done once before they're automated via Prep Conductor. I also want to caveat that this session was rated a Jedi for conference, and we had a lot of back and forth with our marketing team about whether it should be Jedi or advanced, because I personally think none of the features shown here are that complex. It's about as difficult as a join, and I'm hoping everyone in the room here knows what a join is, because otherwise it might be a little bit too advanced for you. But the reason why we kind of settled on that Jedi title is not about the functionality, but it's actually about the thinking hat that you need to put on when you're kind of solving these more complex problems. So on to that, with our mention of thinking hats, we come on to these hats. We're going to be doing this by framing each of the examples from the perspective of two key characters. And this is where those hats came in. So Sasha is from Texas, so I made her our all-American cowgirl, the data wrangler, while I, as the Brit, was the classic British policeman. The database Bobby is a data engineer or database administrator, and they know exactly what's stored in the database and specifically how it's been stored in order to optimize for efficiency in both space and query times in particular. While the data wrangler is an advanced analyst with just one thing on her mind, trying to answer the trickiest of questions that the business has. Now, in each of these examples or stories, neither of our characters are the villains. They both just have a job to do, and they have limited resource to do it with. Our Bobby is, of course, I should point the right way. Our Bobby, of course, is protective of the database and how much it's going to cost to store and process the data. And he, rightly so, might be reluctant to give right access to our wrangler to create those tables for herself. Meanwhile, the wrangler needs a certain structure of the data to deliver the analysis more easily. Otherwise, she's going to end up using complex LODs and table calcs, and if the data was structured correctly, should be able to answer those questions easily. So hopefully, Prep is going to be the bridge between these two characters, and it's important to note that it could be either one of them is the person who's using Prep. We don't necessarily need to differentiate kind of assigning roles and responsibilities when it comes to how Prep fits in this picture today. So on to the actual agenda of what examples I'm going to be covering. I've collected 4 different examples from customers that I think exemplify the concepts behind what scaffolding is. They come from completely different industries, so the key here is the concepts that you're going to take away, but not necessarily the specific use case. That being said, though, all the workbooks, the data sets, the Tableau Prep flows will be made available to you post-conference, along with hopefully a recording of this session, as well as a copy of these slides. So just sit back and kind of let the knowledge wash over you. Don't need to make any notes. So with that, on to our first example. I was exploring some data about which songs made the Spotify Top 200 charts worldwide, and I noticed something interesting. One of the biggest hits from the last few years is 24 Karat Magic by Bruno Mars. It was certified platinum in 9 countries and even won a Grammy last year. For those of you that don't remember or know the song, here's a clip, and hopefully this works.
I bet they know as soon as we walk in. I'm wearing Cuban links, designer mix, Inglewood's finest shoes. Don't look
Just a little sneak peek of Data Night Out as well. Hopefully you'll hear that. And this is a line graph showing us that song's position in the charts in 2017. So the song was actually released at the end of 2016, but as you can see from here, it remained popular throughout the entire year. However, as expected, its popularity waned on, and you can see it started to flatline towards the end of the year. But that chart looks odd, right? It seems to have flatlined. And it's not. The song wasn't in the charts for weeks on end. That's not how it works. What Tableau is doing is filling in the gaps for us on days where we don't have any data by simply joining up the dots. And this doesn't help us identify where there are gaps in the data. Instead, what we'd like to have is a view like this, so we can isolate when the song fell in and out of the charts. So let's take a look at how the data is structured. So from Spotify, this is what it looks like. And the problem here is that when a song falls out of the charts, it's not recorded as a record. We can see there a huge gap between the 29th of October and the 1st of January, where the song isn't in the top 200. And this is a Jedi session, so some of you in the audience might be thinking, why can't we use ZN or zero null to correct this? For those of you that don't know, what that function does is replace any nulls in the data set with zeros. But that's not going to work here because there's no record nor no null to correct. So we need to create those nulls by padding out our data. And this is what we need the data to actually look like. We now have a row for every day of the year, but some of those dates have no position value associated with them, as indicated by the nulls indicated with the red square around it. And this highlights the underlying theme of today's session and the mantra I'll be repeating throughout. Data that's stored efficiently isn't always stored effectively for the analysis we're trying to achieve and the complex business questions we're trying to answer. So let's see how we can use Tableau Prep and a calendar table to help us out here. So let's jump out of presentation mode, and I'll bring up Prep. Ooh. There we go. How many of you guys are already using Prep at the moment? Hands up. Cool. So it's a big proportion of you, so I'm not going to spend too much time explaining much of the interface, as I'm sure it's been covered in many sessions today. So I'll go in and select my database, and I'm going to bring in my Spotify charts data. So just drag and drop into the canvas, and I'll go ahead and straight away add a clean step. So while that loads in, this data set covers all the songs. So the first thing I'm going to do straight away is search for the track name that I'm interested in. So that was 24 Karat Magic. Once that's loaded in, I can go ahead and select Keep Only. So now we're just looking at the one song in the US for that entire year that the data set spans. And this is all I need to do for now. What I'm going to do to pad out the data is bring in what I will refer to as a date dim table. But essentially, that's a calendar table, and a lot of organizations have this built into the database, but if you don't have one, equally, you can just easily create one in Excel. It's as simple as that. And it's literally, as I described, a list of dates, as you can see here from down at the bottom. And if I switch this view to detail, another little Tableau Prep hack is switching it from summary to detail. Shows you every single line item, and you can see that there's one row for each date. And what we're going to do is we're going to drag and drop to join those two tables together. Tableau Prep will automatically, of course, spot the join clause, the date field between the two tables, but it's actually the summary of join results that's key here. Because what we want to do is, rather than doing an inner join, which only keeps the dates that we already have, is we want to use a right join so that we're including all those dates that don't exist in our existing data set. So now we can see the summary of join results is updated to show us all records are included. The last thing I'm going to do here is search for my date field. And here we want to keep the one coming in from our pink data set, the calendar table, because that has no nulls, whereas the original data has those missing nulls. So I'll go in, right-click, and remove field. So now my data set is clean and ready to go. And I can add in an output step to kind of push it out to Tableau Desktop or directly to Tableau Server. I'm going to go ahead and just jump back into Desktop to build that visualization that we saw on screen. This bit should be easy to all of you guys. It's just position onto our axes, date, which we want at the daily level, and we want to reverse these axes because, of course, the number one song is the best place to be. So we want to reverse that. And the last thing I'm going to do is, this is a relatively new feature, so I'll just highlight this one in case you aren't aware, is switching the line type to a step chart. And I just prefer this way of visualizing it when it comes to charts because it makes it easier to spot where the song has flatlined. And straight away, we can see something that we weren't able to see before when Tableau was filling in the gaps. We can see here that it did drop out of the charts for a single day in June, so maybe no one was listening to it that particular day. So let's jump back into the PowerPoint to recap. So to clearly see when a song fell out of the Spotify Top 200 charts and came back in, we need to join in a calendar table that gives us a row for every day in the time period we're analyzing. We learned that when a line item drops out of the data set, there's no record and therefore no null. Padding out the data essentially creates those null values so that we can use them to accurately visualize the time period we're analyzing. Now, if you did want to take this concept away, some examples we thought of to relate this to other situations is things like seasonal retail offerings, like Halloween costumes or Christmas trees that might only be offered during certain times of the year. So with that, it's on to our second example, contracts or subscriptions. And a lot of things in our lives these days are on a subscriptions basis. I've already mentioned Spotify, but if you think of your Netflix, your Amazon Prime, and even Tableau now. This data set is looking at telecoms contracts, and each row in the data set corresponds to a unique contract with what product was sold, when the contract started, how long it will last for, and for how much the total contract is worth. And it's a good data set, there's nothing wrong with it. We can achieve a lot of simple analysis with this structure. I'm sure all of you guys could put these vizzes together in less than 5 minutes, and you could answer questions like how many of each product did we sell, how many contracts were signed this month, and how long do contracts last on average. But as a business, the question that really matters is not when contracts get signed, but it's when we get paid. And this viz shows exactly that. It shows how much revenue we're guaranteed each month based on contracts that we've already signed, meaning that if we stop selling anything more as of October 2018, revenue would stop coming in by early 2020. So let's take another look at that data structure again. It's going to be a challenge with the way the data is structured now because we have a row per contract. But what we really need is multiple rows for each contract, one for each month that a payment is due, i.e. a row for every month that a contract lasts for. So I'm going to jump back a second to contract ID 1 and just focus on that. So contract ID 1 lasts for 11 months from April 2016, and it was for a total value of $330. So in the structure we now need, we'll need 11 rows for that data set with a payment date field so that we can understand when payments are actually due. But also we want to split that 330 total amount across into monthly installments. So again, we're going to jump into prep to see how this example would work. So I'm just going to go ahead and clear my flow and bring out the contracts example from my database. And again here, always best practice, start with a clean step to get an understanding of what a row actually represents in our data. So we'll switch to the detail view, and you'll be able to see that we have one row per contract ID, as I kind of showed in the screenshot before. This time around, because a contract can only last a fixed period of time, let me go back to duration and we'll see that. A contract can last a maximum of 24 months or 2 years. We have a fixed end. So we don't actually need a full calendar table to do this analysis. So here, instead of using a date dim table, I'm going to be using what I'll call a scaffold table instead. So let me drag and drop that in and explain what it looks like. This table is a really simple list of the number of months that a contract could last for. So because a contract could last for 24 months, our scaffold table only needs to be 24 rows, and we've numbered those accordingly from 0 to 23. And we've got a key field in here, which is just the number 1 repeated. And this key field is what's going to unlock the ability to pad out that data. So I'm going to go ahead and add in that extra key over here. So it's just key and the number 1. And if I take these two data sets and join them on that key, it's going to join every instance of the number 1 to every instance of the number 1. And this is called a product join or a Cartesian join. So let me go ahead and do that. And this, the first time I learned about it, I found it kind of conceptually hard to understand. But here in prep, I think it's really easy to see what's going on. We had 1,000 rows in our original contracts data set. We had 24 in my scaffold table, so of course the join result is going to give me 24,000 rows. If I go in and add a clean step to follow, and now take a look at our contract IDs, we'll see now when I hover over that each contract ID has 24 rows associated with it. So we are going to need to do some filtering to take that back down to the 11 that we want. So we can go in and add a filter. This is just a simple filter calculation to check that the number of months is less than the duration. Actually, I'll leave that up on screen for a second. And I'm doing this, and I'll be doing this throughout the session as kind of 2 separate steps, the product join followed by the filter. But it's actually from one of you guys in the community when I presented this at the London user group a few weeks ago that suggested that you could skip that Cartesian join filter step by just doing an unequal join. So I'm going to continue to use the Cartesian join just because I think conceptually it helps you understand what's going on. But performance-wise, I would definitely recommend using the unequal join. So let me go ahead and save this as a filter so that now we can see our contract ID, number 1, has exactly 11 rows, what we needed. For analysis, we won't need the keys. They're just dummy fields, so we can get rid of them. They've served their purpose. And then we've just got 2 more steps. At the moment, our data only has the start date. It doesn't have the payment dates, so we need to build that into our data set. And that's a simple date add calculation. Date add in months. We have the start date and the number of months. Oh, I think I got that the wrong way around. Like so. So go ahead and hit save, and then we'll have those payment dates padded out. The final thing to do is to split that total contract value across those payment months into monthly installments. And that's just a simple division. It will be the amount divided by the duration. So now if we look down at the data grid, our data set has exactly the structure that we needed in the screenshot that we saw from the PowerPoint. So let's go ahead and jump into desktop to see how we'd build this viz. So onto our contracts data. And this time we're looking at, rather than the amount, we'll be using the monthly payment because now we've already split and we don't want to double count the values. So go ahead and bring out monthly payment. And here again, rather than using start date, the correct one to use would be the payment date because that's the one that's been padded out from the beginning. So go ahead and select month. And you can already start to see the shape of the viz form. I think in the original screenshot, we had product on color as well. So product to color, and just switch that to an area chart. And there we have it. So let's go ahead and recap this one. So in this specific example, to understand when our customers needed to pay, we needed a payment day field. So we used the scaffold table to pad out the data from the start date through the duration of the contract. We learned that when one record needs to be represented by many marks, we need to create additional records. And we join our data to a scaffold table that has as many records as the maximum number of times a record might need to be represented. So in our example, the scaffold table was 24 rows because a contract can last a maximum of 2 years. And this concept is pretty easy to apply in other situations, any subscription-based service where payments can occur monthly or annually. So this next use case is one that we see a lot of in our forum. Many companies want to understand their headcount at the end of different time periods, year, quarter, month, etc. It's a pretty standard question. And data tends to be stored something like this. We have a record per employee with their hire date and their termination date. Their termination date is null if they're still employed by the company. But without using a skeleton table at all, we can answer some simple questions. So before I jump into that, I'm going to show you what we can do with the data as is. So we're going to prep. And I'm going to go ahead and connect back to my database and bring in the headcounts data set. And here, again, we add in a clean step so that you can see that each employee indeed does have a row per person. But here, to be able to do analysis, we need to create one single date field so that we only have one timeline. So for that, we need to pivot our data. So take those 2 columns and transpose them into just one row. So I take my 2 dates, I drag them. I'll rename this to event type, and we can call this hire and termination. And then we have the date field already picked up. Whoops. So now my data looks like this. So if an employee's not left the company yet, they'll just have a null for that specific date. So we can go ahead and exclude those because having them and not having them doesn't make a difference. Either way, that date is null. So now if I jump back into desktop with this data set, imagine I hit output and connect to it. We can go ahead and build a visualization to answer the headcounts and turnover rate question. We'll go ahead and bring out date at a yearly level and account distinct of employee ID. Now at the moment, the viz isn't actually showing me what the number of employees working at the company is because we actually now have 2 rows per employee, one for when they started and one for when they left. So the correct way to build this visualization requires some table calculations. We need to go in and pull event type onto color. We now have our hires and our terminations. And then we're going to add some table calculations. So we'll right click, quick table calculation, and I'll zoom in, for a running total is first of all going to show us the total number of employees that have ever worked at the company. That's 645, but we haven't subtracted those who have left yet. So that's the next step. So this is where we go in and edit our table calculation to add a secondary calculation to calculate the difference from, and here the difference is between event types rather than years. And then just because of the way the hire and termination is ordered alphabetically, we need to say this is relative to the next. So now this is our accurate view of what headcount looks like. We now know that we have 366 employees with the company, not the 645 you saw before. So the next question is, of course, what is our turnover rate? And for that, we need to know how many people did we fire. I shouldn't say it like that. People who left, for whatever reason. Employee ID, I'll bring in again to create a dual axis. And you'll see, of course, Tableau Prep creates that additional marks card with event type on it. And this is a really neat little Jedi trick that I learned during this session, is if I need to keep those table calcs protected on the top visualization, but I want to make changes in the bottom, then I can go ahead and duplicate event type, up here, drag that onto color, but note that as I do it, I'm doing it on the marks card for just that specific bottom visualization. And what this means now is that in my bottom visualization, I can go ahead and hide, so not exclude, because exclude will exclude it from the entire visualization, just hide those hires. So now my bottom view shows me my terminations, and my top view shows me my actual running count of employees. And we've done that without affecting the table calculations that underlie that visualization. So now calculating turnover rate is easy enough. It's going to be this, for example, in 2017, it's this 51 divided by this 354, so about a 1 in 7 per year. Let's go ahead and jump back to the PowerPoint to see where this example might not be as robust as we think it is. It's the way we define turnover rate. In our current definition, we're always looking at the number of active employees at the end of the year. Let's take an extreme example. Let's say I'm CEO at an organization, and at the beginning of the year, I have 1,000 employees. And suppose in June, there's a major economic upheaval, something like Brexit or the Great Recession of 2008. And sadly, I have to lay off 500 of my employees. So with our current definition of turnover, we'd have 100%, because we have 500 people leaving and 500 people left at the end of the year. But this definition doesn't consider the fact that for the first half of the year, we did have 1,000 employees. So a more accurate definition of turnover rate would be to look at the number of people who left over the average daily headcount, the average number of employees working on every single day across an entire year. But for that, we need our data structure to match that type of analysis. And here what we need is a record for every day that an employee has worked at the company for. So we need a calendar table, one that has a record for every single day that the company has been in existence for. And again, keep in mind that this is not going to be the most efficient way to store the data, because again, we're going to have a lot of extra rows. But the benefit of using Prep here is that it stops you from having to store this huge amount of data in the database, nor does it require having to perform some of those complex joins on the fly, since it's going to be based on those extracts. So in this case, the database Bobby should be a little bit happier. So let me go ahead and show you how. So let me clear the pivot step and bring in my date dim table. So like I said before, this one is a calendar table. Unlike the Spotify example, this one needs to go a little bit further back. It goes back to the 60s, just because this is when this fictional company has been in existence for. And here we're going to do exactly the same thing. It's a key-to-key join, or a Cartesian join. So key is 1, and I always pick 1, but equally just for efficiency, but it could be, ABCD, it could be your own name, as long as it matches in both data sets. So key to key. So that now if we go ahead and join, that one-to-one relationship is found, but of course we don't need a row for every employee for every day that the company has been in existence for. We only need a row for every day that they've been working for. So we're going to go in and add a filter. And I've got short keys set up for this because I can't type that fast and I don't want to get it wrong. So I'll give it a second to just load in that calc. So what this calculation is doing is it's comparing our calendar table to the hire date and the termination date. And what it will do is it will ensure that the calendar is only being kind of brought in where the hire date is, let me get this right, is before the calendar date, and the calendar date should be in between the hire date and the termination date. There we go. Or the max of today if they're still working with the company. So before I hit apply, let me show you in this data preview, that join that we did is resulting in millions of rows because of the sampling, but also because of that data duplication. And here, by adding this filter, it's going to reduce that amount of data down dramatically. So we'll give that just a sec to load in as well. So that now we're just down to 50,000 rows, and we don't need to use sampling because all the data can be pulled through. And again, we can get rid of our keys because they're not needed in our analysis. And then we're ready to jump into Tableau Desktop to complete our analysis. Go ahead and do that. So this time around, again, we're going to be doing a count distinct of our employees. And this time we're using, again, the calendar date, the one that we've just added in, rather than any existing dates in our data set. And the nice thing about this is that that running total that we had to previously compute is already built into the database because now we've changed the structure of it. So that previous shape that you saw that we had to do kind of 2 table calcs to get there is now built into the underlying data. So the next step, if we're calculating turnover rate, is going to be the number of people who left the company that year. So for that, we just need to write a simple if statement calculation. Let me make this bigger. So it'd be if the calendar date matches a termination date. Because if there's no termination date, they haven't left the company yet. So we don't care, they don't count as someone who's left. Then, let me actually split this across a few lines so everyone can see. Employee ID and then end. And I'll call this. So now we can do a count distinct of those guys. The final thing to do, though, is to calculate that average daily head count. That's the thing that's still missing from this viz. So for that, we're going to need an LOD. Create calculated field, and I'll call this average daily head count. And remember now what a record represents in this new structure of the data. A record now corresponds to every day that an employee was working with the company for. So our LOD is going to include the calendar table, which is not in our viz, so we're telling it to go down to a lower level of detail, the total number of records in an average. So the average is still computed at a yearly level, but we're computing it relative to how many employees were working on each and every day. So I'll go ahead and hit OK. And I'll bring that in, and I'm going to pop it in between just so we can see the difference in numbers. So if I go in and pick on a year, let's pick 2017 again, we can see the running total says 405 employees, but the actual average daily head count says 350 employees, and that's because 50 left during the year. So it's an average of how many people were working across the entire year. So it's our more accurate or more robust measure. So the last thing to do is, of course, compute the turnover rate. That's just simple division. So turnover rate is going to be the terminations divided by the average daily head count. I can get rid of this, and I'll switch this to a simpler bar chart. And because of the way the data is now structured, I can go in and add a filter and not worry about it affecting my table calculations as with the previous example. So we can see the most interesting things with this company happened in the last 10 years. So let's go ahead and filter to just that. And say last 10 years. And my values aren't affected. Whereas if I was using a table calculation, everything would now be referencing as if the company had only formed in 2010. So back to our slides to recap. Scaffolding our headcounts data with a calendar table helps us understand employee tenure and turnover at a daily level. Joining in that calendar table asks us to ask more robust and complex questions because we have access to the additional date parts. With that viz I showed you, I could easily just hit the plus and go to a quarterly turnover rate, a monthly turnover rate, a weekly turnover rate if I wanted to. And you can use these concepts in so many different areas. Think operations or support with open and closed tickets or cases. In healthcare with admitted and just discharged patients, or in hotels with room bookings. Lastly is our most complex example. So this one we're going to go a little bit more slowly on. So imagine a smart home where every device, light switches, washing machines, TVs, absolutely everything is being tracked. This data is stored by device ID. We've got the start and end timestamp, as well as the state that that device was in. Also note that the end timestamp always matches the start time for the next state that it was in. And the viz we want to build looks like this. I want to know the proportion of time each day a device spends in each state, so that I can start to spot usage patterns and make changes to live a more energy efficient lifestyle. And you obviously know the drill by now. We're going to need to pad the data. But here, the original data that we were looking at is down to the seconds level of detail. And for those of you who have a date dim table, I'm pretty sure you don't have a seconds dim table, if that's a thing. And how do we go about building that out? You can easily create one by using the same concepts from the second example, the contracts example, by joining on a dummy key to a scaffold table. Here we just join in an hour, minutes, and seconds table. And the hour table is going to be numbered from 0 to 23, because there's 24 hours in a day. And the seconds and minutes are going to be numbered from 0 to 59. So all this is doing is just doing those product joins again and again to create from a calendar table to a seconds calendar table, a timestamp table, let's call it. So suppose our data wrangler did that behind the scenes. She's pretty smart. She came to TC. She came to this session. She took that lesson away and did it. And she did the same thing. So she padded out the data and then filtered out the redundant records. Let's take a look at what happens. So now we have a record for each second that a device was in a particular state. So that first row we're looking at was one row originally. It's now represented by 43,000 rows. So if you take that across all the devices we have in our house, across all the different states it could be, we're actually taking our original 50K data set to over 500 million rows. So I know even the data wrangler is probably going to be mad about this, not just the database Bobby. So let's take a deep dive into why that is. Let's take this simple example. My device is off between the 12th of August at 10:09 p.m.-ish to the 15th of August at 7:38 a.m. in the morning. But because of the way the data is structured, this is going to result in a whopping 200,000 records just to tell us that the device was off for a little over 2 days. What if I told you that writing a few simple calculations helps us cut down this 200,000 to just 4? We have to think back to the visualization that we were trying to build at the beginning. That was at a daily level. So we only need 4 rows for this because there are only 4 days that this device spans that specific state across. And we do that with 4 calculations to help. We need the duration on the start date. So that's from the timestamp on the first day through to midnight on the same day. Then we need the durations in between. These are whole days in between, so that's just the whole of the 13th and the whole of the 14th. And then finally, we need the duration on the end date. So that's midnight on the 15th through to 7:38 a.m. So we kind of split it out into chunks. So let's see how we would do that in prep. Clear my flow again. And bring in my smart home devices data set. So here we've got our start time, our end time, our device ID, and device state. And before we even begin the analysis, the first thing I'm going to do is go ahead and create a duration calc. And this duration simply is the date diff in seconds between our start and end time. And we're going to be using this to create that duration on the start date, duration in between, and duration at the end calculation. So this is the foundation of it all. So now that I have that, I can go in and bring my normal calendar table, and I'm going to prove to you that it is a normal calendar table by showing you. There's no timestamps here, just dates. And I already have the key built in. So that's one thing I need to go back to my data set and add in. So here, like before, key to key, we perform that join. And immediately we're going to have some duplication, so I'm going to go ahead and filter out those records. And what this is going to do is, of course, doing that product join, that Cartesian join, is going to give us, it's going to give us dates spanning the entire calendar table, whereas we only care about the start and end time, so between those two. So all this does is truncate that start and end timestamp and make sure that our date from our calendar table is between those 2 days. So I'll save that. At the same time, go ahead and remove my keys. Cool. So now we have to go ahead and build those 3 calculations out. So let's start with the hardest one first, and you'll see why when I show you what it looks like. So duration on the start date. And this is a short key that's loading in. So like I kind of explained with the slides, is what this calculation is going to do is it's going to first of all check, is the start and the end date the same? Because if it is, we've already got the answer. It's the duration calc I just wrote. If not, then we just want from the start timestamp to midnight on the same day. That's all that this is doing. And it looks scary, but the workbooks and the flows and everything will be sent to you guys afterwards, so you can kind of take the time to absorb it in properly. So now that I have that, the next thing to do is duration in between. So any whole days in between, we want to count those. This one's a little bit simpler just because of the way we've defined it. If it's a whole day in between, then we just need to add 24 hours, whatever that is in seconds, to our data as a column. So 24 hours is 86,400 seconds. So that's what this one is doing. Last but not least, I'm going to go add in the duration on the end date. This is similar to the start and end one. Oh, I might mess it up. This is similar to the first one in that if the start and the end date were the same, then we don't need this calculation. So we're just looking at midnight on that end date through to the end actual timestamp. So again, that's what all this, I've added in kind of commentary to explain that as well. But what this really means, if you actually look at the data grid, is that at any one time, only one of those 3 columns is going to be populated. You're never going to have a value in more than one of them. And so we need to kind of compress these so that we get our actual duration in one column. So for that, I'm going to create a final calc called total duration, which is just my duration at the start, add my duration in between, add my duration at the end. And go ahead and save that. And we can go ahead and clean up this data set, remove all those kind of skeleton calcs that got us to this point, because all we need is that total duration calc, that very final one. So let's go ahead and jump into desktop to see how we go about building that viz. So for this one, because it's the last example and I want to have a bit of a wow moment, I'm going to go ahead and pause creating the viz. Even though it's a Jedi session, I think this one's always worth mentioning, is pause means you kind of stop Tableau building the viz until you go ahead and hit play. So it gives you the time to drag and drop, and if you know what you're doing, you can like build a viz in 5 seconds and then let everything run once. And it's pretty fun. So here we want a sum of our total duration broken down by device ID for each day in our data set, So you'll see here our date only goes down to a daily level. It doesn't go down any further. And then we want the device state over on color. And we want this as a bar chart. And I think that's all the pieces. So if I hit play, we should get our viz in one click, or a few clicks. Yeah, and what this essentially shows is exactly the question we were trying to answer, right? It shows us the proportion of time a device spends in a particular state, so that we can start to spot if something is in an idle state when it shouldn't be, if something is on at the weekends when it shouldn't be, or during the day when people are out of the house. So, last one to recap on. With this one, the viz only needed a daily level of detail, so we actually use a simpler form of scaffolding, but with calculations to derive the level at that lower level of detail. So the scaffolding is at a daily level, but the calcs are at a seconds level. And this is because when scaffolding results in a data explosion, it's really important to go back to the original question and ask yourself, do I need that level of granularity? Not just for kind of confusion and your own sanity, but also for performance. And you can use this example, again, all over the place. A few that I thought of were manufacturing, of course, with machine production line effectiveness, with on and off times, facilities management with device, seat, or space utilization, so room bookings again. And the final one is kind of my favorite, and one that I want to turn this example into, is a time card, employee time cards. So employees come in and punch in and out every day, but also during breaks. But we might only pay them on a weekly and monthly level. So their time cards are stamped down to the minute level, but we only care about the data at a weekly or a monthly level. So with that, I want to remind everyone of our mantra one last time. And as with any mantra, it's probably good for all of you guys to say it as well. So on the count of 3, if you could, I would love it if you joined in with me. So 1, 2, 3. Data stored efficiently is not data stored effectively. Thank you. Otherwise, that would have been very awkward. But what this does mean is a happily ever after. Padding our data with a scaffold or skeleton or calendar table, whatever flavor you want to call it, allows us to bridge the gap between efficiency and efficacy. Tableau Prep is keeping both of these guys happy and not compromising on the analytical integrity nor the database efficiency. We have a visual and direct interface to see the changes we make easily. We're working off extracts, so those large volumes are not processed against or stored in a database. And we only need to do these tasks once before Conductor takes over, and we can schedule them as often as we need. So that brings me to the end of this session. Please, as with every session, go ahead and complete the session survey on the My Evaluations tab on the app. These ratings matter to us because we take the feedback into account as we improve this content for next year, as well as conference over in the US. So with that, thank you. I'm happy to take any questions from the room. We have a roaming mic, but also I'll be sticking around at the end. Thank you, guys.